Alrighty, hello. This is Kenneth Corrigan again, and today I'll be presenting section 4 of chapter 8, which covers the development of climate models over time, how they've progressed through time, how they've improved. They've constantly improved, just like anything else, I guess. Alright, so for just a quick introduction, climate models are very complex programs. They're constantly growing and they're constantly becoming more sophisticated and more encompassing, more all-encompassing. This picture here represents the progress of climate change models since about the mid-1970s. As you can see, they've progressed with each decade, and pretty substantially with each decade up until the early 2000s, which this graph covers. And you can see it went from just the atmosphere, just like the temperature, anything else that can relate to, all the way up to atmospheric chemistry. I don't even know what that means. Dynamic vegetation, whatever. Carbon cycle, I know that. But the climate change models, the more sophisticated ones, such as you see here in the mid-1980s open and sea ice model, you can see how that developed separately, but then into the early 1990s it was integrated into a more comprehensive model, and with each integration the model becomes more comprehensive. So these complex models are first developed separately and then integrated to make a more comprehensive model. The models on the bottom, obviously, are those that are created separately, and the arrow there represents their integration into a comprehensive model. And you can see some of them even form together, or may even take a couple of decades for them to be integrated into the models. I mean, you can see the atmospheric chemistry at the bottom there. It took from the early 1990s until the early 2000s for it to be integrated in. Now I find this model accurately relates the complexity of the development of climate models. Alrighty, so why the development? Well, early climate models were clearly primitive to those we've had today, but this can be largely contributed to the lack of computing power that was available, and with the improvement in computing power, the models that are made separately can be integrated into the more comprehensive models. So some of the inaccuracies of global climate models. First of all, no model can accurately predict the environment at every single point on the Earth, as this is scientifically, mathematically, and technologically impossible. As you can see, this kitty cat here is aggravated that its weatherman or woman did not provide an accurate forecast. Maybe it didn't think there was going to be so much snow, and essentially doubts the science behind the prediction. Clearly, this is not a very learned cat, but it brings up a valid point that suggests that there still remains a lot of improvements to come that we can expect from global climate models, or GCMs. They're also referred to as GCMs. And finally, resolution is very important. Now, the resolution of a GCM is important to describe the development of them, as well as to describe the accuracy of the model. The reason that the models cannot reasonably predict or display the environment at any given point on Earth, besides the fact that they'd have to take it down to the smallest level of each atom that exists on Earth, is because there simply is not enough computing power. Instead, global climate models essentially divide the globe into a grid of squares, as you can see here. Starting from the top left, going down to the bottom right, they become more sophisticated. So these global climate models divide the globe into a grid of squares, and predict the climate within that particular square, within each particular square. Earlier climate models started off as big as 1,000 kilometers per square, but as they've become more advanced, models have broken them down to 100 kilometer grids. Additionally, climate models must represent depth, which varies by the advancement of the model. As you can see above, the most advanced of the four models, AR4 at the bottom right, seems that as though it displays more land, but this is only due to the increase in depth perception. So it looks like it's covering more, which essentially it is covering more data, but it's not covering more land, only specifying and predicting the weather to greater accuracy with each grid. The resolution of the model is very important, as it is a huge determining factor of the specificity that a global climate model can have, or can predict. These are the sources I used. Note the lolcats for the angry cat picture, and voila.